Hey everyone, this is Tariq King, Chief Scientist over at Test.ai, and welcome to my session, AI for Game Testing. It's all fun and games until the tests fail. So let's get into it. When I was younger, I used to think, man, what if I could get a job if there's someone who would just hand me a controller and say, hey, you know what, play video games all day and I'll pay you, right? And I used to think, man, how cool would that be, right? And it turns out that there is such a job as game tester, but it probably is not what I thought it was all cracked up to be, right? You see, we're motivated to play games for a number of reasons, which are very different from the reasons for testing games, right? Like we want the achievement to advance the game and learn the system and the rules and to compete with other people. The social interaction aspect of it, right? To form that connection, maybe have some smack talk or, just be part of a group effort if we're playing co-op. And then finally, like just to be immersed and be taken away from the real world and escape into that unique story or journey that the game developers are trying to take you on. However, when we're testing the game, like our motivation is very different, right? Of course, there's some element of whether or not the game is enjoyable, right? But that type of validation is not usually left until the end when someone's about to hand you the controller, right? Rather, when you're testing a game, you're focused more on making sure that the features of that gaming application actually work, right? Can I navigate the menus and that sort of stuff? Or maybe looking for cosmetic bugs or glitches or trying to break that gameplay mechanic, right? Like just trying to see if we can find those types of weird things that the game is doing that it shouldn't do. And so, this is not a really a knock on game testers or people that are testing video games. It's really more of an appreciation, right? I think many of us in the testing community don't really appreciate exactly how hard of a problem it is to test games, right? So first, when we're talking about testing games, the first thing to recognize is that we're dealing with this infinite space, right? And you might say, well, yeah, sure. As testers, we deal with an infinite state space all the time. Well, that's true. Like for an enterprise app where you may have like 100 screens that are 10 levels deep, and maybe each level has about 10 input fields. Like that's still something you can count and that you can map natural numbers to. Unlike a game where at any moment a player can choose to wear something different or equip some item, go somewhere and do something when you get there. And all these interactions that you're going to do with both non-human and human players, right, that are also going around this maybe environment non-deterministically. And then the game content itself is always evolving, all this downloadable content to bring new skins and maps and weapons and mods, right? And as you can imagine, even running through visual regression checks every time an animator updates a visual could be quite tedious, right? And repetitive, right? And so, you know, and then on top of that, there's little to no automation, especially when it comes to the end-to-end piece, right? Like there's, Selenium and Appium aren't going to help you with navigating this game application per se. And even if they did, how are they going to help with, validating the visuals and that kind of stuff, right? And so this kind of highly repetitive manual effort normally is something that companies tend to outsource or really not even do. And your dream job all of a sudden doesn't look that dreamy, right? After all. Nonetheless, game testing is critical, right? Like, might ask, well, why, right? Well, we have 2.5 billion gamers worldwide, and each of those of a large consumer base are purchasing games and subscribing to gaming services or buying DLC and more. And just last year, which was a hard year financially for many, we saw a 20% increase in global sales when it comes to games, right? Because people are at home, they're locked down, and what are they going to do? Well, try to do things to enjoy themselves. And we're not just talking about console and PC gaming here. Roughly half of the revenue, which is the total revenue of like $175 billion, half of that came from mobile gaming, right? And so, you have people being attracted to that because of the low barrier to entry. Everyone has a smartphone and just ready to go, right? And now we have game streaming that they can actually stream very high-end games to a smartphone or tablet, right? And so we're projected that by 2025, that the global gaming market will be worth around $250 billion. And once you start talking about those types of numbers, well, testing becomes very, very important, right? All right, so let's look at some of the different dimensions of game testing so we have a grasp of the problem, right? So the first thing is always what to test, right? And in fact, we've kind of mentioned some of this stuff already, right? There's the purely functional side of the game application, right? Navigating through certain use cases and changing the language or toggling on and off some setting, right? And a subset of that that's very important, especially for revenue for these big companies, is the in-game store, right? Can I purchase an item? Can I add it to the cart, submit that payment, and then access the purchase item? And then, of course, a key part of that is that does it even look or feel right once I purchase something like that, right? Gamers are very finicky beings, and if they, sense that hey, I just bought this skin and it doesn't look right, they want their money back, or they could just walk away altogether, right? And last but not least, the whole gameplay experience, right? Which again has different sub-dimensions: functionality, performance, accessibility, and the whole user experience. Another dimension is on where to test, right? So you have your gaming clients, right? Your personal computers, your game consoles, your mobile devices, right? But then that is only half of it. There's the client, but then what about the server, right? There's the data streaming services like Stadia, PlayStation Now, or Microsoft xCloud, right? So you got to test that server side when it comes to streaming. But then there's also just the App Store platform, which is just a distribution center, but many of them are now morphing into these subscription services, where instead of just purchasing an individual game in the store, you have a subscription fee and you have access to a collection of games, right? So things like Apple Arcade and Google Play Pass, right? And so there's a significant level of effort to make these platforms conform to certain guidelines. That all needs to be tested: installation, security, app stability, and then how do these things actually compare the different games in that store to each other in that category? Like, can we test that, right? Like at Test.ai, our mission is to test the world's apps, and so that means comparing these domain groups against each other and seeing how they perform, and so on and so forth, right? Of which gaming is a subcategory. All right, so just like other applications, you also got to think about the level of testing and at which point during the development cycle that testing occurs, right? Currently, a lot of the testing for game development occurs like during that development period on the core game logic, right? And so at this level, you might have an internal scripting language, like, for example, Unity has the UTF, the Unity Test Framework, formerly the Unity Test Runner that integrates with NUnit. And so you have all your kind of JUnit and the next unit familiar type sub-automation. But however, most debugs that happen when it comes to games happen more during rendering than at that game logic level, right? And so at best, the current strategies around rendering might be to spin up something in a bare bones development environment and check the aesthetics there. And it's far from that end user experience, right? And so the whole idea is that, like, hey, we have this gap between dev and the end user, and automation especially doesn't really happen in that end user experience. Most of that testing on the end user experience is that manual testing that tends to get outsourced. So that brings us to the final dimension, right? This whole idea of looking at testing from a manual test strategy, right? What are the techniques and scenario-based testing, exploratory testing, all those different things we're applying, plus maybe the regression testing that needs to happen for the visual validation and all the assets. And then your automation, right, which is currently very limited in terms of the current techniques and tools that are out there. And so the whole idea behind a lot of what we're talking about today is that, like, we have AI, right? And AI has been playing games for as long as we can remember. So why not have AI also test these games, right? And I'm not just talking about tic-tac-toe or chess or Go or even Atari games, right? I'm talking about AI playing like heavily multiplayer games like Dota 2 and League of Legends and Fortnite, right? And AI learning these games by playing several iterations against itself and reaching an expert level. And these things are hard, and you don't have to take my word for it. You can go and check OpenAI. There's a lot of gaming research over there. And so if we can do that kind of stuff with AI, then all of a sudden extending the box with classifiers for detecting cosmetic issues or even gameplay bugs doesn't really seem so hard anymore, right? And so the whole idea of AI for game testing is that we want to leverage this technology to be able to bridge that automation gap, and especially specifically in the context of games, right? And so I'm going to share a lot of our work on AI for game testing. And this is not just theoretical or conceptual stuff. There's actual work we've done to put real AI in production systems and to test games and gaming applications that you have today, right? And very complex ones, right? And so we're going to cover how the bots are doing build verification testing, both locally and in the game streaming servers. We're going to look at scenario testing and covering the app functionality of the game, verification of the gaming assets, both visual, the animations and stuff, as well as the sound and sound effects, right? And then testing the game streaming software and the data centers that power them, and then putting all these things together to really find bugs in the whole gameplay engine, right? And all automatically, all using AI, right? And so it's been a lot of work to get to this point, but it's exciting stuff. All right, so build verification, right? Just first thinking about the local client, you are thinking about performing some sort of smoke test on the gaming client, right? And so this involves your typical DevOps stuff, right? You need to be able to automatically deploy or install your new build. And this is nothing fancy, there's nothing that requires AI here at this point. But beyond that, when AI starts to become useful, it's thinking about actually logging on to the game client, dismissing any modals that pop up because of the new build or the clean install, and then actually navigating the smoke path and verifying, the screen that you reached on for the smoke test, right? And the smoke test will stop the line. And so the whole point here is that leveraging AI brings a number of benefits, even through the navigation of this application, right? And so the whole idea here is that whether you're talking about a smoke test or a functional UI test, is that you want to train the bots to recognize elements on the screen just like a human would, right? And so on this particular screen, the bot can recognize elements such as the play icon and the shopping cart and so on and so forth. And it also realizes, just as we would, which icons happen to be active. For example, here, the play icon is active, right? And so it classifies it as play active icon, right? And so not only is AI kind of a requirement here, right? Because, the traditional tools, the Seleniums, the Appiums don't help you, but they're added benefits, right? And the key here is the two R's that we like to hear about in test automation: robustness and resiliency, right? So on one end, once the AI is looking at these things just as we would as images, when they change, right? Like, for example, in a new build, maybe that nav bar is styled a little bit differently, right? And maybe the position is now at the bottom of the screen. Well, the bots don't get thrown off by that. They just look for that icon. They recognize that, hey, I think that this is the play icon, right? And still clicks it. So your automation doesn't break, and it kind of can withstand these changes without any maintenance, right? Which is a beautiful thing. The other part, which is resiliency, is kind of similar, and people use these terms interchangeably, but resiliency has less to do with just withstanding changes and actually adapting to changes, right? And so a key part here is the way that the bots navigate through the application using something called reinforcement learning that we'll touch on a little bit later, is that if you change the flow of the application, even structurally, because the bots are using reinforcement learning and a more, navigate to the character select screen, right? It's not taking these step-by-step instructions. It has the goal of getting there. And so by trial and error and using a reward system, even if that flow changes, the bots can still reach to that navigation path, and not only just reach there, but actually learn an optimal path to get there using those rewards, right? And so that's pretty cool that we have that level of robustness and resiliency in the automation. And so here it is, just a cool example of like the fact that, if you're a Lord of the Rings fan, like one AI-based script to rule them all. So all these different pop-up scenarios, like we don't have to train specifically to handle each one of these things. We can train a general classifier that's able to dismiss modals for new installs or new items or new events, right? It doesn't matter. These things tend to be quite tricky when you start talking about in-game and things popping up. And that kind of non-determinate behavior is usually very hard to test. But with AI, we can handle them all, and not only just handle them, but handle them efficiently in one script. All right, so now shifting to visuals and audio and kind of asset verification in general, right? So the first step, once you start talking about visual verification of assets, is the idea of localization, right? Where we are now saying that the bot needs to identify the location of a visual asset within an image, right? And then draw a bounding box around it, right? And so you'll hear us talking a lot about training a chopper, which is basically just using AI to identify the objects and the elements on the screen and then cropping them into separate images, right? And so in other words, we are just chopping the screen up into these smaller objects. And this allows us to either label those individual elements for training or have AI predict or suggest labels for what they think those things are, right? And this latter part is really the classification problem, right? So predicting a label or a category for an element, right? And this aspect of AI is very generally applicable and very useful, right? So for example, here with asset verification, we can train the AI to individually recognize a particular character, right? Or different backpacks, right? Or combinations of these things, right? So here it recognizes not only that this is the character Maverick, but he's also wearing a specific backpack, the adventure pack, right? And so now you can think of a test case that travels through the game, equips certain customization, and then at the end can verify that what was selected is indeed exactly what appears on the character, right? And so that's pretty cool, right? To be able to do that. Another key thing is like, well, can you detect differences, right? And just thinking about looking at visually an application that is very graphically intensive, just simply detecting changes and knowing and distinguishing between whether or not these changes are wanted or unwanted is a pretty cool thing, right? And so you can train the bots on some baseline visual that represents the norm or the prior observation, right? And things that you've seen in the past that are normal. And then the bot can compare what it sees during a test with that baseline. And obviously the goal here is to identify what has changed. And so we call this process visual diffing. And it starts by basically removing the background for the model and then comparing that current observation, which is your test, from the prior observation, right? So here we ran this on soulmachines.com. They have digital avatars. And, in the default mode, we see here that, hey, prior observation, the bot here or the avatar here was not smiling, but the current observation is that it's smiling. And so what we can do is take the diff here and create a diff mask, right? Where we can say, well, here's what looks like what changed, right? And it's pretty cool to be able to just identify, okay, something changed, but how do we know and can we distinguish between changes that are wanted or unwanted, right? And again, it all depends on what you define as your baseline, what is your normal, right? So for example, in another look at this, we can have a current observation where the avatar is blinking, right? Her eyes look like they're shut down, right? And the prior observation is the same. And you would expect when you subtract this diff mask that you don't just get the smile, right? Like you're looking at me like, well, why is it just the smile? And well, didn't we clearly have like some difference here with the eyes being open versus shut? And the question here is really answered by looking at the training data and understanding what the bot has learned. Remember, this is not a static image, right? This is a video that is animated, right? And so the training data looks and even in the default state can tell that, hey, blinking is something normal. And so I don't need to flag that as a change. But the smiling, and in this case, the bots don't smile unless you smile back at them. That change is only going to happen and will cause something different from the baseline because something external happened with the application, right? And so you can kind of see how it can learn, wanted change versus unwanted change, right? All right, so how do we deal with this all in production to give testers something useful to look at? Well, we kind of overlay the diff mask with the actual image, right? So that if there's any glitches or anything that came up in the diff mask, you can see exactly where on that image the change occurred, right? And then decide what action you want to take. All right, so just like there's visual, there's also audio, right? You think about these things in prod really are animations that have sound, right? So swinging the knife. So you have these sound effects that go along with the animation, right? And how can you do validation on the audio, right? And so what we do is we create some spectrograms here just to illustrate how this works, right? But you have a baseline audio signal, right? Which again represents your previous observation. And then you have your current observation, which could be your test case, right? And the whole idea here is that, similar to how we look at diffing and differences, you can look at the similarity of these things. And what we do is create a sliding dot product, which is basically a cross correlation to see, well, hey, does this particular signal, irrespective of amplitude, actually occur within the baseline, right? Can we actually do that cross correlation? And once you can, then you can now validate, yes, you know what, the sound that I thought should happen actually did happen, right? So it's another way to look at the whole problem, whether you talk about difference or you talk about similarity. Whole idea is that you have a way to validate these assets to make sure that they conform to what you think. All right, so getting into more of the latter part, now we talk about now the server side and the streaming, right? And so there's several, these services that have a streaming app, and then obviously there's the server side that needs to be dealt with, right? And so you want to think about how to test those, and again, using AI to do build verification there is also quite powerful, right? You can have tests for cloud games and for console games that live in the cloud. You can test the game menu and that sort of stuff, all on different platforms: Android, iOS, Windows, web, etc. And also collect performance stats and even have videos that show you what was happening when this particular test happened, right? And so you start looking at launching games as part of that, right? The success rate. You can look at the data centers and how are we performing by data centers. There's an issue launching games from a particular pod or a particular data center that is out there, or is it a problem with the game title, right? And starting to look at that dimension of it. There's also the aspect of the timing, right? So you might really care to find out, hey, are games stable? Are they underperforming or unstable, right? Where a stable game is, you can launch it successfully within some time period. And underperforming is that, hey, it's no longer hitting some time threshold that it used to within the past 2 weeks, or maybe it's completely unstable and you actually don't have timing results for that particular game, right? And so, and looking at different dimensions, fresh launch versus launching to the title menu, loading an existing save state, or a completely new game, right? So there's quite a bit of testing that can happen there. And then what about the stream quality, right? We've done a lot of work and shared on testing video quality, right? And emulating the human judgment of mean opinion scores. Well, how does that translate into the gaming world? And this is something that we're looking at. And if a game stream isn't rendering properly and has issues, you could actually zero out the whole gaming experience, right? People get frustrated. So how can we leverage that work to actually help us with the game streaming problem? And these bots are actually out there finding real bugs, right? So these are real bugs that are being found on the streaming servers, being able to make sure and look and see, hey, these streams are taking long to load or connections are lost and that sort of stuff. And it becomes critical, right? And our bots not only go through and actually find these bugs, but they report these bugs and file them automatically through the streaming app, right? So, when you start thinking about building testing as a feature, a lot of apps now have what is really a bug reporting mechanism built in there. Well, our bugs can actually, during testing, actually, if it finds a bug, submit that bug, or after the fact, go back and submit all the bugs to that same system. All right, last but not least is the gameplay, right? Like the whole idea here, and once you start thinking about games, is let's do testing on that game engine, right? And testing for games tends to be quite loosely scripted, right? So you don't really have these step-by-step instructions. You have high-level goals, right? Win the game, lose the game, right? Check for different player characters and how they interact in the environment, or the interaction with friends. Like those are your tests, right? And so here we have a test running against League of Legends that says, well, spawn and attack the minion, right? And that's your goal, right? And as I mentioned before, a lot of the way that we realize this stuff is through reinforcement learning, right? So you actually can now sit down and say, okay, well, let's give the bot rewards for scoring kills, right? Or penalize him for camping, right? And then, do a lot of training on the different features that you care about and give a lot of rewards where you expect the bot to do something that you want it to do or penalize other things. And once you iterate through those episodes, the bot starts to become better and better. and the bot can play Doom and kill monsters and stuff like that. And behind the scenes, you have a model that just has the things that you're interested in, right? The monsters, the med packs, and the ammo. But at the end of the day, the bot learns, well, let me not camp, spin around and kill things and walk around and get better at doing so, right? And while it's doing that, right, even if you train that bot with the sole intention to, win the game, the agents can actually just do things like break the game physics and find exploits, right? Ceiling glitches, jumping through walls or jumping on walls in a weird way, and all that kind of stuff, right? So we're just extending that whole framework that's there for gaming and all the research and applying it to software quality. All right, so since we're trying to do testing like humans and reinforcement learning, and figured, well, why not have the bots actually control, the games like a human, right? So, without sharing too much of our secret sauce, we can basically spoof game controllers with a Raspberry Pi and then, send USB signals to emulate the controllers, right? Analog sticks and D-pad and button presses and so on and so forth, right? And once that's all wired up into the bot framework by the controller, we can hit most of the consoles like PS4, Xbox, and even the Nintendo Switch, right? And another cool thing here is that a lot of this work is done in a general way that it applies to next-gen consoles like the PS5 and the Xbox Series X. All right, so to bring it all together, right, we have this kind of goal, right? We can leverage all this research for gameplay and then put it all together for testing, right? That goal-based exploration, the real-time object detection, the reinforcement learning, controller emulation, the audio-visual asset verification, and the video quality piece, right? Our bot here is walking through and has these goals, right? Explore the location, collect weapons and ammo, open the treasure chest, equip upgrades, and score a kill. And with instructions like that, and being able to then do visual validations and verifications along the way, provides for a very powerful framework for finding bugs and issues in games, right? So I hope you guys kind of really see the power of this technology and like what we're able to do and how interesting and hard this problem is, right? And, just to kind of give credit where credit is due, there's a lot of people that helped to build this stuff. It's not just me or it's not just Jason. We're all here working collectively to solve some very hard problems using AI. So hope you guys engage in the Q&A and just thank you. You can reach out to me via email or add me to LinkedIn after the conference. Thank you.